This question talks about a ball doing a circular motion on the inside of a funnel. The forces acting on the ball is its own weight, which is vertically downward, and the normal contact force that the funnel exerts on the ball. The question states that there's no frictional force, so these are the only two forces acting on the ball. The fact that this ball is doing a circular motion tells us that the direction of the acceleration is always centripetal, towards the center of the circle, which is right here. We know that when the ball is at this position, the acceleration is horizontal, leftward, pointing towards the center of the circle here. Now, since the acceleration is purely horizontal leftward, we know that the summation of these two forces should result in a horizontal net force with no vertical component at all. Because of this, the clever thing to do is to resolve everything into the vertical and horizontal directions. In the vertical directions, all the forces should balance, because we already know that the net force is purely horizontal and has no vertical component. In the horizontal direction, the forces are of course not balanced, but we can equate it to the mass of the ball times its acceleration. So this line here is saying, in the vertical direction, the upward component of the normal contact force is balanced by the downward pull of gravity. So n cosine 60 degrees is mg. Well, you have to figure out first that this angle here is 60 degrees, but once you have figured that out, the vertical components of the normal contact force, you can see quite easily, is n cosine 60 degrees. Work with this right angled triangle here. Now let's work on the horizontal direction. In the horizontal direction, all we have is the horizontal components of the normal contact force, which can be written as n sine 60 degrees. Again, work with this right angled triangle here. So n sine 60 degrees can be equated to the mass of the ball times its acceleration. But since this is circular motion, we know we can write the acceleration as v squared over r. So really what we're looking at here is just net force equals to m times a, except that we have replaced a with v squared over r since this is circular motion. And the rest is mathematics. Again, we have two equations. We divide this equation by this equation. The normal contact force gets cancelled out, the mass gets cancelled out. So we have tangent 60 degrees equals to v squared over rg. Put in all the numbers and you can get the radius, which is the radius of this circle here, to be 0.0712 meters. Quite a nice question. I hope you have fun doing this question. And thank you for using XM Physics.